Hello. I am going to try to make these videos about 5 minutes. So each lesson will probably be broken up. There's some road work going on outside my house, so if you hear some beeps, I'm really sorry. There's nothing I can do about it. I'm going to remind you of what we started off with. Right before spring break, we were working on section 4.1. We were talking about solving systems of linear equations by graphing. When we're asked to solve a system of linear equations, we're being asked to find a point, an ordered pair, you need to remember that, it's an ordered pair, that solves both equations at the same time. Now the first problems we were working, we were given a potential answer and a system. In this case, we have two equations. And that's what you're going to see in this class and in intermediate algebra, but once you get into college algebra, you're going to start working these with three. Okay? Now what we were asked to do is to check to see if this was the solution to this. And what we mean by that is that this point needs to work out in each of these 2 points. So what we did was we took the 4 for this first equation, and this is our x, so I placed it where the x is, placed the 3 where the y was, and then we did our arithmetic. We ended up with 10 equals 10, which is true, so it worked here. Now that's not enough to say it works for the entire system. It has to work in both. So we had to do the same thing with our second equation. We plugged in 4 for x, 3 for y, we did our arithmetic, and we ended up with 27 equals 3. So that is not an answer. Here we did it again. And we plugged in 9 for x, 1 for y. This is our first equation. When we plugged it in, we got 18 equals 18, so that's true. For our second one, we did our arithmetic and we got 27 equals 27, which is also true. Now what we talked about here is, if you recall from chapter 3, these are both lines. And I stressed to you that lines have meaning. They're not just pictures we make you draw and we're picky about. Every single point on a line is a solution to the equation. So the theory behind what we're going to do now is, if I just drew random lines here, they don't necessarily correlate to these. If this is all the answers to one of them, and this is all the answers to the other one, the point they have in common, right here, where they would cross, that would be our answer to our system, because that would be the only point that they share. And in this case, they cross at 9, 1. So if we draw the pictures, if we draw the two lines, they would cross at precisely the point 9, 1. We did one more. We plugged in -9 for x, -2 for y. We did our arithmetic and we got -8 equals -8. Now you need to be really careful with your signs on these. I saw in your last test that there were quite a few issues with that. You have a calculator, make sure you're using it. For the second equation, we had to check both. Plugged in -9 for x, -2 for y. We did our arithmetic and we got -39 equals -39, which is also true. So this is a solution to the system. Our two lines would cross at precisely this point, -9, -2. Now I'm going to backtrack to our first one. We did the first equation first, okay? We could have started with this one. If we had done this one and we found out it didn't work, we wouldn't need to check this one, because it wouldn't matter, because both answers need to be correct. Now this is what we would do when we are solving systems, which is where we're headed, and we want to check our answers. So this is how we would check our answers. Okay. In the next video, we're going to talk about some more theory, and then we'll work at least one problem.